Thinking about the evolution of the GTR. Skyline GTR. It has evolved along with the race. Challenge, feedback, and proof. And on to new challenges. The GTR has been forged in this way. I am proud that it has repeatedly reached the top of races and met people's expectations. At the same time, I am keenly aware that even greater heights await. And now, on to the R33 GTR. We have taken on the challenge of further expanding the area in which it can be controlled at will that was realized in the previous model. Controllable at will means the car moves as the driver intends, it does not move contrary to expectations, and the car speaks to the driver. From the planning stage, we concentrated each of the performances of running, turning, and stopping on one axis called driving performance, and carried out thorough development. By pursuing enhanced maneuverability, we have evolved the potential to fully utilize the capabilities of four wheels and provide the fun of driving. The 21-second reduction in lap time recorded by the R32 GTR at the Nürburgring is nothing less than an objective indicator of faster and safer driving performance. And now, the GTR has achieved a more practical potential increase, aiming to improve driving performance and durability under all conditions. One example of this is the newly designed large front spoiler equipped with a large opening air duct for cooling the brakes. This is proof that the GTR's driving has reached a level that can even be used for limit driving on a circuit. What did we do to make the most of the capabilities of all four wheels? Part 1, GTR chassis potential. Impact area of the four tires. In other words, it is essential to improve the performance of the tires and at the same time have chassis performance that can maximize the potential of the tires. This is the basis of the R33 GTR's goal of the ability to drive fast with confidence. We made improving cornering performance a major theme. To achieve this, rather than simply reducing understeer and making the characteristics more oversteer-oriented, it is necessary to first ensure stability, improve the ease of understanding of steering information and vehicle behavior, and then increase front grip. Specifically, we improved the suspension, steering, yaw rate feedback electric superhykas, tires and road wheels. We promoted comprehensive development of brakes, drive system, body rigidity, etc., and achieved expanding the range of control at will. Front multi-link suspension faithfully responds to the driver's steering. Accurately conveys information about the road surface. Ensures stability not only when driving straight and turning, but also when braking. The GTR's front multi-link suspension, which balances these qualities at a high level, has been further refined. It has evolved into a front suspension for stable, faster driving. For example, the upper link has a bifurcated structure that sandwiches the shock absorber, increasing camber rigidity by approximately 35%. By maximizing the potential of the tires up to their limit, the range in which the car can be controlled at will has been expanded. In addition, the spring constant, stabilizer diameter, shock absorber damping force characteristics, and bush rigidity have been tuned in conjunction with the rear suspension to significantly improve road contact. Furthermore, the addition of a front strut tower bar and a front crossbar has improved responsiveness to steering. It emphasizes the comfort of feeling as if your nerves are one with the car. Rear multi-link suspension. The GTR's driving is based on stability up to ultra-high speeds on the circuit. The main role of the rear suspension is to keep the tires firmly on the ground and ensure stability by suppressing changes in posture even when powerful driving and braking forces are applied. The rear multi-link suspension fulfills this role precisely. In this GTR, the wheel stroke on the bounding side has been increased by 10% compared to the previous model, further improving ground contact. This ensures that the tires are pressed firmly against the road surface in the correct posture, ensuring high stability. In addition, the high rigidity obtained through careful measures such as increasing the bush rigidity and increasing the camber rigidity by about 20% functions to fully utilize the potential of the rear legs. And all the elements that make up the four-wheel multi-link suspension, including the front legs, are integrated with all the vehicle components, large and small, to truly realize an expansion of the range that can be controlled at will. Electronically controlled power steering. Two types of hydraulic control valves are arranged in series to electronically control the appropriate amount of steering assist according to the driving conditions. When steering stationary, both valves are fully operated simultaneously to increase the amount of assist. At high speeds, only the first stage valve is operated to maintain firm steering force. The high-precision steering gear, polished to a micron level of 1/1000 mm, provides a direct steering feel. The joy of tracing the intended line through corners, and arrow-like straightness on the highway. The GTRS steering system allows the driver to control the car as he or she wishes and communicate with the road surface in a variety of situations, always giving the driver a sense of unity. It acts as an interface. Yaw Rate Feedback Electric Super Hikas was born to improve steering response and stability more faithful to the driver's senses. And the Yaw Rate Feedback Electric Super Hikas is an evolution of the function that directly leads to the expansion of the ability to control the car at will, further pursuing our idea that the driver comes first. This is the car that reads the driver's intention as the target yaw rate, and feedback controls the steering angle of the rear wheels so that the yaw rate actually occurring in the car matches the target yaw rate. This has given the GTR a new dimension of 4WS performance that can actively respond more faithfully to the driver's intention. The fun of pointing the nose precisely at the target point and clearing corners while staying perfectly on the line. The deep sense of security that maintains stable tracing even on rough paved roads and in strong crosswinds. It is a system that amplifies the close and trusting unity between the driver and the GTR. Brembo brake system plus high-performance ABS, achieving basic capabilities commensurate with the absolute power. Response to instantaneous sudden braking. And braking with a pedal feel appropriate to the braking. The role of the GTRS brakes is extremely important and demanding. It is a battle against heat. For this reason, we adopted a brake system made by the prestigious Italian company Brembo. Its greatest feature is the diamond-shaped lip used in the ventilation section of the large-diameter brake rotor, front 324 by 30 mm thick / rear 300 by 22 mm thick. This not only has excellent thermal strength and stress distribution, but also achieves a significantly larger surface area than conventional radial rectangular lips. Combined with the use of high-carbon material, it exhibits an extremely high heat dissipation effect, about 1.5 times that of the same size rotor in our cooling index ratio, ensuring sufficient fade resistance even under severe braking, such as when driving on a circuit. The front wheels also feature opposed piston aluminum calipers with different diameter dual pistons, with a small diameter of 38 on the entry side of the brake rotor and a large diameter of 444 on the exit side. The brake pads have a uniform surface pressure distribution. Together with the high rigidity calipers, it provides stable braking force and pedal feeling even at high speeds. Furthermore, the ABS, anti-lock brake system, that comes standard on the GTR provides stable braking on rough roads, as well as thorough tuning of ABS performance for sports driving. In addition to the overwhelmingly high braking performance when braking from high speeds, the system has improved line tracing performance by minimizing the behavior changes in the yaw direction, such as under/oversteer, which tend to occur during ABS control. This allows the ABS performance to be faithful to the driver's intentions and is appropriate on a variety of road surfaces, both dry and wet. It plays a part in the GTRS goal of being able to drive faster and more stably. Specially developed Potenza RE010 and 17X9JJ forged aluminum road wheels as part of our efforts to enhance the chassis potential of the GTR, we developed a high-performance tire. This tire is the Potenza RE010 245/45ZR17, specially developed for the GTR. While achieving an excellent balance between various requirements such as straight-line stability, cornering, and drainage, the tire's contact area has been made as wide as possible. This tire has achieved grip performance that reliably transmits the GTR's powerful high power to the road surface with stable traction and controllability. Moreover, the road wheels are newly developed 17-inch X9JJ forged aluminum. The wide rim allows the tire to use the entire tread width to grip and kick the road surface. In addition to being lightweight and highly rigid, it also has extremely high precision, such as roundness and uniform tensile strength. Brembo brake rotor ventilation structure. The ventilation section of the Brembo brake rotor is made up of 3 types of diamond-shaped ribs. This creates a much larger surface area than the general type, which has rectangular ribs arranged radially. Large opening air duct for brake cooling in the large front spoiler. A new large front spoiler has been adopted that increases the opening area of the air duct for brake cooling by 26%. By efficiently introducing a larger amount of running air, the brake cooling performance during continuous braking from high speeds on a circuit, etc., is improved by 20% compared to the conventional air duct. What should be inherited? What should be challenged? 2.6-liter twin-cam 24-valve twin-ceramic turbo, RB26DETT engine. This power unit has proven its absolute performance superiority and reliability through numerous victories, even in the N1 race specification with limited scope of modification. And for the R33 GTR, we sought room for evolution in the RB26DETT. In particular, we made various prototypes and verified the turbocharger. As a result, we confirmed that there is no better unit for the GTR at this stage. We pursued the best torque characteristics and throttle response for the R33 package, and worked to expand the range that can be controlled at will. We performed detailed tuning on a wide range of aspects, from the intake system to the exhaust system and engine control program. At the same time, we also refined the characteristics of the electronically controlled Truk Split 4WD Atessa ETS. Another new initiative was the installation of new air ducts in the front bumper, making full use of know-how gained from N1 racing to improve the engine's cooling performance. We'll leave the details of these to the pages that open this cover, but our theme was to refine the car to achieve more neutral and controllable handling performance, and based on that, to improve endurance for limit driving on the circuit. It is precisely because we possess assets worthy of inheritance that we take on the important role of challenging itself to further evolve. What we feel is the joy of being with the GTR. What did we do to fully utilize the capabilities of all 4 wheels? Part 2, GTR driving performance. Sodium-filled hollow exhaust valve. Metallic sodium is filled into the stem of the exhaust valve. Metallic sodium is solid at room temperature and liquefied at high temperatures, which increases the thermal conductivity of the entire exhaust valve and suppresses temperature rise. Direct-acting lightweight inner shim-type valve lifter. A shim that adjusts the valve clearance is placed on the inside to reduce the weight of the valve lifter. The lightness and response of the entire valve system is improved, raising the limit of valve surging at high revolutions. High-rigidity cylinder block. The explosive energy generated during the combustion process tries to push the head away from the cylinder block. In order to withstand this energy with ease, large head bolts are used. Combined with the rigidity of the engine and transmission connections and the high-rigidity design of the crankshaft and connecting rods, it is able to handle the high output of the RB26DETT engine. RB26DETT engine straight 6, 2,568 cubic centimeters twin cam 24 valve, 6 throttle chamber, intercooled twin ceramic turbo. While following the basic specifications that have proven its absolute superiority in races, the RB26DETT engine has improved performance as a power source for the GTR in a new package called the R33. The main menu is increased torque. The maximum boost pressure of the turbocharger has been increased from 570 mm of mercury to 620 mm of mercury, and the intake temperature has been lowered by a newly developed intercooler. The intake resistance has been reduced by a lightweight plastic air cleaner, and the ignition timing and mixture ratio have been refined. Maximum torque has been increased to 37.5 kgm/4400 rpm. It's easy to say this in words. However, the power unit of the GTR, which is designed to win races, is faced with unimaginably harsh conditions, such as the throttle being turned on and off in a split second. The control of the ignition timing and mixture ratio must be able to meet this demand. As I will explain in detail later, we used our own Hokkaido brewing ground and the famous Nürburgring as important stages for development. For example, in the final stage of tweaking the engine characteristics, the engineer in charge rode next to the test driver who had the ability to determine the characteristics to within 1 to 1 second. The driver's comments while driving were compared with the information from the data logger that kept recording the engine condition in detail, and the torque response while driving was refined repeatedly so that it would faithfully respond to the driver's will. In other words, we focused on satisfying the demand based on the driver's keen sense of "I need more torque here" when he momentarily pressed the accelerator. Even simple tasks such as controlling the ignition timing and fuel supply were organically synthesized by repeating this kind of running and verification. And the speedy control by the 16-bit centralized control engine computer, which has significantly increased the processing speed, supports stable and linear power response. The RB26DETT engine exclusively for the GTR. Its overwhelming power and controllable performance are the result of a perfect harmony of tradition and innovation. Twin ceramic turbocharger. As mentioned earlier, the turbocharger was retained. Compressor side, Garrett T3 type/turbine side, hybrid type T25 type with ceramic rotor. The lightweight ceramic turbine with a small moment of inertia realizes a sharp response from the low rotation range, and by installing it in twins, exhaust interference is prevented, and a linear and generous supercharging effect is achieved from the low speed range with low exhaust flow rate to the high speed range with large exhaust flow rate. Quick response and high power are both achieved throughout the entire range. In addition, the turbine material has been improved with the increase in maximum supercharging pressure. Durability and reliability have been improved. Inner fin type high-efficiency intercooler. The inner fin type is used for the intercooler, which cools the air pressurized by the turbocharger, increases its density, and further improves the supercharging effect. The core, called the conventional multi-hole tube type, was made of layered aluminum material with several holes running through it, and had a certain thickness inside. In contrast, the inner fin type is made of 0.1 mm thick aluminum fins that are wavy at 1.4 mm pitch and wrapped in aluminum plate, with all joints brazed. This has increased the heat dissipation from the conventional 16,800 kcal/H to 17,500 kcal/H. Same time, it has been made smaller and lighter. Since it is installed in the front overhang with cooling efficiency as the top priority, this weight reduction directly translates into a reduction in the vehicle's yaw moment of inertia. 6th throttle chamber. The 6th throttle chamber is one of the important items that support the GTR's sharp and linear throttle response. There are very few examples of it being used in mass-produced cars. This is a system in which the chamber is placed close to the cylinder head and a throttle valve is attached to each cylinder manifold. Since the capacity from the throttle valve to the intake port is small, the intake response to the throttle is quick. Not only does it provide overwhelming acceleration response at full throttle when driving on a circuit, but it also provides extremely sharp and flexible response in the partial range when driving normally. Exhaust system with large capacity muffler. Reducing exhaust resistance is essential to enhance power. However, this increases the exhaust discharge sound. In order to balance these conflicting themes and further refine the sound taste, a newly developed exhaust system has been adopted. First, the capacity of the rear muffler, which was previously 16 liters, has been increased to 19.1 liters. Moreover, the joints inside the muffler have been designed to allow the gas to flow smoothly, improving the sound quality of the exhaust discharge and reducing exhaust resistance. The larger diameter of the two front tubes just downstream of the twin turbos, 460.5, and the dual tail tube also contribute to reducing exhaust resistance. We hope you will enjoy the original power of the RB26 DETT along with this uplifting exhaust sound. We also hope you will enjoy the beautiful shine of the dual tail tubes, which are made of the highest quality stainless steel SUS 304 and have a color that changes subtly the more you drive. Electronically controlled torque split 4WD Atessa ETS. The core of the numerous technologies that exist to fully utilize the capabilities of all four wheels is the Atessa ETS, inherited and evolved from the R32 GTR. Based on FR, it is an electronically controlled torque split 4WD system that distributes torque to the front wheels in response to changes in driving conditions. The drive force distribution is continuously controlled from 0:100 FR equals rear two-wheel drive to 50:50 rigid 4WD. In addition to vehicle speed and accelerator opening, the drive force distribution to the front wheels is controlled according to the values detected by the wheel speed sensors of each of the four wheels, the front and rear G sensors, and the lateral G sensors. For example, when the difference in rotation speed between the front and rear wheels is small and the lateral G is large during turning, the front and rear torque distribution is brought closer to 0:100 to make it FR. Sharp turning ability and vehicle controllability by the accelerator are given top priority. Furthermore, when the difference in rotation speed between the front and rear wheels increases, part of the torque of the rear wheels is sent forward to optimize the yaw moment of the vehicle. It enhances vehicle stability and allows the powerful driving force of 4WD to exit corners. In addition, the torque distribution during high-speed cornering on dry roads, where large lateral G-forces are generated, is set slightly more toward the rear wheels than before in the R33 GTR. This further reduces understeer. When lateral G-forces are small, such as when starting, climbing, or accelerating in a straight line, or on low roads such as icy roads where the rear wheels have a large amount of slip, the torque distribution to the front wheels is increased to generate stable traction unique to 4WD. Furthermore, the comprehensive control of the torque split and ABS, anti-lock braking system, optimizes braking and ABS performance on various road surfaces. The GTR's electronically controlled torque split 4WD Atessa ETS. This further refined system conveys to the driver the joy of stable, faster, and more precise control in all driving situations. Key item for improving engine cooling performance: the front bumper now has the same air duct as the N1 race specification. This increases the air speed passing through the radiator, improving engine cooling performance. In addition, an air-cooled engine oil cooler that significantly improves oil temperature cooling performance when driving on a circuit has also been newly set as a dealer option. It can also be installed on cars equipped with air conditioning. Nismo Sports Engine Oil Cooler, air-cooled. The air-cooled engine oil cooler has high cooling efficiency and prevents oil performance degradation due to rising oil temperature and adverse effects on the engine itself, making it an essential item for sports on the circuit. It comes as a set with a dedicated air intake. Rear mechanical LSD. It optimizes torque distribution when the driving force of the left and right rear wheels changes due to driving on uneven roads or road surfaces with different left and right wheels, or when one wheel spins during cornering. The torque-sensitive mechanical LSD of the GTR responds more faithfully to accelerator operation than a rev-sensitive viscous LSD. It enables direct differential limiting and supports vehicle control through active accelerator work. Packaging of dynamic performance. As I have already mentioned, in developing the GTR, we have combined everything around the single axis of dynamic performance. And the most symbolic example of this is the performance related to the body, especially the body rigidity. For example, the RB26DETT engine exerts tremendous acceleration on the body it sits on with its overwhelming power and torque. The suspension, which is mainly composed of the four-wheel multi-link suspension and a Tessa ETS, takes on that acceleration and tries to twist and bend the body by competing with the grip of the tires. In other words, the body must have rigidity that is more than enough to withstand it. Otherwise, no matter how high the engine and chassis boast, they will not be able to sublimate it into the fun of driving at will and provide it to the driver. Furthermore, where and how much rigidity should be provided? How to balance strength and lightness? Or how to utilize weight distribution and aerodynamic load distribution as support performance for traction and handling. The addition of new rear floor stays and an increase in rigidity equivalent to adding another rear strut tower bar are the result of repeated meticulous design and testing. Engine, chassis, body. Their close, complex, and inseparable relationship. This is the very essence of the dynamic performance we have been pursuing. What did we do to make the most of the capabilities of all four wheels? Part 3, GTR Body Construction. Sensitivity and body rigidity. When we decided to use the R33's two-door coupe body as the framework for the GTR, we thoroughly re-examined it. It goes without saying that the body already has an extremely high level of rigidity. Detailed simulation analysis using CAD. Measurement of torsional rigidity and bending rigidity using prototypes. And the rigidity of the two-door coupe body has been developed through repeated running. It has the potential to be the framework of a grand touring car that represents Japan. However, when it comes to the GTR, which has overwhelmingly high engine performance and naturally aims to win races, the required level of technology is even higher. Also, if the tires were a little softer, the various types of loads input to the body would be somewhat mitigated. However, such compromises are not acceptable. In order to achieve the body rigidity we were aiming for, we ended up making further improvements to as many as 30 parts. First of all, we made use of the experience and data accumulated in Group A races. We also performed repeated simulation analysis. We also verified changes in rigidity using a variable body rigidity test vehicle that we developed as one of the means of pursuing dynamic performance. But still, some problems remained unsolved. As the potential of the R33 GTR increased, we were moving to a level that required even more advanced technology. As we searched for a solution, the answer came from the sensibility of our GTR development test driver, who has the best driving skills and evaluation and analysis capabilities among us. A keen human being can sense behavior that a computer cannot explain. After all, it is humans who give life to a car that they drive. Overall and local rigidity. Front strut tower bar. Triple crossbar consisting of 3-part pin stays arranged on the left and right body shells. In addition to these rigidity options, a new rear floor stay has been added to firmly support the rear floor panel and suspension mounting parts. This ensures high rigidity for the rear suspension mounting parts, equivalent to adding 1 strut tower bar. These further improved overall and local rigidity have achieved steering response and turning ability, reduced rear response delay and improved ground contact, easier to grasp vehicle behavior, and improved steering information. In addition to deepening the sense of security during normal driving, it also embodies the overall effect of improving controllability at the limit, such as uniform connection during four-wheel drifting, making it easier to grasp behavior. High traction layout. The GTR has been designed to be lightweight with meticulous attention to detail. Moreover, in order to distribute the load on the front and rear tires as evenly as possible, emphasis was placed on optimizing the front-rear weight distribution. The company sought to create a package that would stably demonstrate the inherent potential of the engine and chassis and provide high traction. This is the high traction layout applied to the GTR. At the same time, the weight of the parts mounted on the so-called overhanging parts outside the front and rear axles was also reduced. This is to reduce the yaw moment of inertia, which directly leads to improved turning performance, by placing heavy parts as close as possible to the center of gravity of the vehicle. The main weight reduction items related to the high traction layout are as follows: a small and lightweight inner fin type intercooler, a plastic air cleaner, a power steering pulley that is positioned back toward the crankshaft to avoid an increase in the overall length of the engine due to a larger cooling fan, abolition of hydraulic pumps and piping due to the electrification of the Supericas, high-stress coil springs used on all four wheels, front and rear aluminum axle housings, a miniaturized ABS actuator, plastic headlamp outer lenses, battery positioned at the rear, and of course, aluminum front bonnet and front fenders. You can see how much importance was placed on optimizing the front-rear weight distribution of the GTR, and how much effort was put into reducing the weight of the overhanging parts. And I think you can also see that in order to achieve this high traction layout, it was necessary to bring together all of the wisdom, experience, and technology from all areas, not just the body design. The higher the dimension of driving you want, the more the laws of physics stand in the way of the car's performance. In terms of the relationship between the suspension and the road surface, it is acceleration, and in terms of the relationship between the body and the atmosphere, it is air resistance. Here too, the GTR pursues aerodynamic characteristics that make full use of the capabilities of all four wheels. The aim was to firmly press the tires of all four wheels against the road surface and utilize the available traction to improve handling performance without waste. Then, based on a body silhouette with excellent basic aerodynamic characteristics, wind tunnel experiments and actual driving tests were carried out countless times. While optimizing the front and rear lift balance, the shape of the blister fenders that cover the two 45/45 wide tires, as well as the shape of the front spoiler and variable rear spoiler were determined. In this way, the GTR suppresses the lift of the front wheels and sets CLF equals 0.09 and CLR equals -0.03, variable rear spoiler, standard position. Combined with an air resistance coefficient CD of 0.35, it maintains stable traction without losing grip on the front wheels, helping to achieve both aero-like straight-line stability and high-speed cornering performance at a high level. The angle of the variable rear spoiler can be adjusted in 4 stages using the onboard tool, but the true value of using this function is only revealed on the racetrack. The standard position provides the best balance when driving on public roads, so we recommend using it in this position. Speed on the circuit and safety performance. Now, let's talk about the safety performance of the GTR. Nissan aims for comprehensive safety with the triple safety of information safety, which improves the driver and the car's ability to avoid danger and prevents accidents, control safety, preventive safety, and impact safety, crash safety, minimizing damage to passengers after an accident. It goes without saying that the premise for all of this is the basic performance of running, turning, and stopping. And in the GTR, which takes limit driving on the circuit as its ultimate stage, the key technologies that embody that basic performance are the 4-wheel multi-link suspension, the electronically controlled torque split 4WD Atessa ETS, the LSD, the ABS, and the high rigidity body. You get the idea. The GTR's pursuit of expanding the range in which the car can be controlled at will is, in other words, aimed at achieving the ultimate in driving pleasure, while at the same time achieving extremely high levels of safety performance to prevent accidents before they occur. And what amplifies and enhances the safety performance woven together by this excellent basic performance is the triple safety that I will now introduce. On the circuit, it provides excellent controllability at the limit, and on public roads it provides the ultimate in a comfortable and close sense of unity with the car. Our approach to pursuing the true value of safety performance in the GTR is consistently multi-layered and meticulous. The joy of controlling it at will also comes with the ability to avoid danger. And with triple safety in place, you can be absolutely sure of your safety. Information safety, ensuring clear visibility to grasp the surroundings to safely and at will. The driver must be able to quickly and accurately recognize the driving environment at that time. And the basis of this is information safety centered on visibility. Therefore, the GTR has newly adopted xenon headlamps. This is a light-emitting tube, bulb, filled with xenon gas, which emits light by creating an arc discharge between two electrodes. It features more than twice the amount of light compared to conventional halogen lamps that use filaments as light emitters, and a natural white light that is easy to see and does not tire the eyes. By taking advantage of this high amount of light, the irradiation range is expanded, significantly improving visibility in the distance and on the road shoulders at night. In addition, the amount of retro-reflected light on wet road surfaces is doubled, ensuring good visibility even in the troublesome driving environment of a rainy night. Information safety when driving in the rain is also improved by the newly adopted long-life water-repellent glass on both sides of the front doors. This glass is coated with a long-lasting water-repellent layer, which helps to repel raindrops and maintains clear side visibility. In addition, the wide-angle door mirrors, dealer option, which have a gradually decreasing radius of curvature on the outer side of the mirror surface, provide approximately 1.5 times the visibility of conventional door mirrors with a fixed curvature. This makes it easier to see cars approaching directly beside you, especially when changing lanes or merging onto the highway. On the other hand, visibility, or how easily you can be seen by following vehicles, is also an important factor in safe driving. The GTR comes standard with high-mounted stop lamps that clearly indicate your intention to slow down by braking. Control performance to prevent accidents by further enhancing the excellent basic performance of running, turning, and stopping. The control safety area plays a role in enhancing risk avoidance capabilities and preventing accidents. One of the high mechanisms for this is the yaw rate feedback electric super hikers. This reads the steering angle, vehicle speed, and actual yaw rate, and appropriately feedback controls the steering angle of the rear wheels to maintain a driving line faithful to the driver's will. It maintains stable tracing not only when cornering, but also on rough roads and strong crosswinds. ABS, which makes it difficult for tires to lock by controlling the brake fluid pressure by a computer, is also standard equipment. Through comprehensive control with Atessa ETS, it demonstrates appropriate ABS performance under various road conditions, making it easier to avoid obstacles by steering. Moreover, the main brake system is equipped with Brembo aluminum caliper opposed piston brakes on all four wheels. It ensures powerful stopping power that can easily handle the overwhelming power of the RB26 DETT engine, while also providing an extremely rigid brake pedal feel. It also has excellent controllability that allows for bold yet delicate braking. The control safety of the GTR. This is nothing other than the potential that supports the fun of safely controlling a car at will. Crash safety, zone body concept and dual airbags as standard equipment in preparation for the unlikely event of an emergency that cannot be prevented. The GTR has improved the safety performance of the body itself with the zone body concept, crushable zone and safety zone. The zone body concept is a system that absorbs the impact of an emergency in the event of an emergency and protects the occupants with two zones, the crushable zone plus safety zone. In the event of a front or rear collision, the crash energy is absorbed by the crushable zone of the car body to soften the impact on the occupants, and the high-strength cabin made up of sturdy frames, members, pillars, etc. ensures a safety zone, survival space, for the occupants. In addition, in the event of a side collision, the impact is dispersed by the strong side door beams built into the doors. Effectively suppresses deformation of the cabin. Based on this high level of crash safety, the GTR comes standard with dual airbags, drivers and passengers SRS airbag system. In the event of a frontal collision, the airbag instantly inflates and, together with properly fastened seatbelts, cushions the impact on the occupant's head. The front seats are equipped with 3-point seatbelts with tension reducers, ELR, that reduce the feeling of pressure. The rear seats are also equipped with 3-point seatbelts with ELR. In addition, the vehicle is equipped with a driver's seatbelt unfastened warning light that reminds the driver to fasten the seatbelt. Harmony with the environment, looking to the future for the coexistence of people, cars and nature. Nissan is committed to the concept of coexistence of people, cars and nature, and is mindful of the environment in all stages of the process, from manufacturing to use and disposal. For example, to protect the ozone layer, it uses ozone-safe air conditioners that use a new refrigerant, HFC 134A. To make effective use of global resources, it uses easily recyclable thermoplastic resins in various parts of the car, and uses recycled materials in many parts, such as roof insulators, sound-absorbing materials, and trunk linings made from recycled felt. In addition, it is working on a wide range of initiatives, such as reusing scraps of parts generated during the manufacturing process. It also uses aluminum radiators and heater cores that do not use lead solder, and plastic fuel tanks, and is working to reduce the amount of lead used. In addition, paint guard film is used instead of the conventional wax type as a surface protection material that coats the body when transporting a new car. Since it can be easily removed without washing, it contributes to preventing water pollution caused by wax leakage, and is a new initiative that also looks to recycle paint guard film as a resource. The position of the V-Spec. It is a historical fact that the GTR aims to challenge speed. We have advocated for this with the R32 GTR, and have proven it with our results in Group A races. To be fast on the circuit means being able to control the car accurately and stably at will. Speed is an objective and quantitative indicator of the high level of dynamic performance that we refer to. This is also the true meaning behind our continued focus on speed. The R33 GTR, which pursued the ability to run faster and more stably, followed the normal evolutionary line of the GTR. At the same time, we took on the challenge of developing the R33 GTR V-Spec. This V-Spec is based on the dynamic performance of the original GTR, but it has stepped into a more advanced realm of driving. It is not a matter of hierarchy or hierarchical relationships. Speaking from the perspective of the creator, we have not only improved the limit performance, but have sharpened the driving performance by imagining the face of a driver who wants to fully enjoy the taste of that realm. It was this V-Spec that improved the lap time of the R32 GTR by 21 seconds at the Nürburgring. We want drivers with advanced driving skills and adult rationality to drive this car. Its dynamic performance is very high, and the ride is filled with a sense of security, but in terms of enjoying it to the fullest, it is probably beyond the reach of average drivers. What drove the new evolution of the V-Spec was the Atessa ETS Pro and the Expedia S07 Plus 9JJ wide rim. Of front and rear driving force distribution, 100 km per hour. During driving, an example of the control characteristics of the front and rear driving force distribution of Atessa ETS Pro is shown below. When the front and rear wheel speed difference is large and the lateral acceleration is small, when starting, climbing, accelerating in a straight line, etc., the front wheel driving force increases. Even if the front and rear wheel speed difference is large, the front wheel driving force decreases when the lateral acceleration increases due to turning, etc. In addition, when accelerating while turning with a large lateral acceleration, as shown in the example of the active LSD control characteristics in the figure below, the differential control force of the active LSD is strengthened and the driving force distribution to the front wheels is set large. This achieves strong traction, especially on dry roads and at high speeds during turning acceleration. How to utilize the capabilities of the four wheels in the V-Spec. We talked about the function of the Atessa ETS in the GTR original. Based on the V-spec, the FR driving is changed steplessly from 0:100 to 50:50 depending on the driving conditions. It is a system that truly utilizes the capabilities of all four wheels. The V-spec combines this with an active LSD and is equipped with the Atessa ETS Pro, which pursues traction and controllability in areas closer to the limit. Symbolically, it is to further increase the speed on the circuit. The specific development goal is to reduce the lap time at the Nürburgring by 20 seconds. And the most important benefit is to provide the driver with the ultimate joy of driving. Active LSD adopted. Atessa ETS Pro. The key point of Atessa ETS Pro is the active LSD. LSDs are primarily responsible for preventing the inside drive wheel from lifting up and spinning due to roll caused by cornering, inner wheel spin. This is called differential limiting force, and in general LSDs, the viscous coupling or gear unit receives the rotation speed difference and torque generated between the left and right drive wheels and controls it mechanically. In contrast, the V-spec active LSD literally actively and proactively electronically controls the LSD's hydraulic pressure. In other words, the optimal characteristics can be set by tuning the computer software. In the V-spec, the active LSD raises the upper limit of the differential limiting force. This raises the limit at which inner wheel spin occurs, and the outer wheel that is in contact with the road surface can secure traction to move forward. In this case, if it were a simple FR, the accelerator would not be pressed. This is because the car is running only on the outer drive wheels, and if torque is added to them, the drive wheels will spin, which can lead to excessive oversteer. However, the V-spec has the original torque split function of the Atessa ETS. By distributing the appropriate torque to the front wheels, stable traction and controllability are maintained. Moreover, because the rear wheels maintain sufficient traction thanks to the active LSD, only a small amount of torque needs to be sent to the front wheels. In other words, understeer is minimized. In addition, by controlling the ABS together with the torque split plus active LSD of the Atessa ETS Pro, it is also capable of maximizing ABS performance. The technology of electronic control is often seen as the polar opposite of the feeling of natural. However, if you experience the extremely natural, overwhelmingly fast and reassuring driving of the GTR, as represented by the V-spec, I am sure that any preconceptions you may have about electronic control technology will be completely wiped away. The issue is not whether it is mechanical or electrical. What kind of joy and happiness can that technology provide to people? It is a question of the will of us, the builders, who are trying to pursue that. Specially developed Expedia S07 and 17x9JJ forged aluminum road will Bridgestone Expedia S07 245/45 ZR17 tires specially developed for the GTR V-spec. We aim to significantly improve grip performance on dry roads while maintaining the same high level of wet performance as the R32 GTR tires. In other words, we aim to achieve the traction and controllability that would allow us to achieve our major goal of shortening the Nürburgring lap time by 20 seconds. The basis for this is the ultra-wide size of 245/45. In any case, the basic principle is to expand the tire's contact surface, where all dynamic performance is concentrated, as much as possible and increase its capacity. Moreover, it is required that the entire tread of the tire be in uniform contact with the road surface. Therefore, the tire cross-sectional shape is made extremely square, the steel belt width is expanded, and nylon reinforcing cords are added to increase rigidity. It has improved grip performance. It has promoted the expansion and uniformity of the contact area. The tread pattern is asymmetric. On the outside, the grooves are narrowed to reduce the negative ratio of the area of the grooves to the pattern surface. By improving the rigidity of the shoulder blocks, it supports excellent grip performance in dry conditions. In contrast, the inner pattern has a thicker groove to increase the negative ratio. It has achieved excellent wet performance with excellent drainage. This tire is fitted with 17x9JJ forged aluminum road wheels. The rim width of 9JJ is the widest size that can accommodate 245 size tires. This makes the tire profile even squarer, further expanding the contact area. The Expedia S07 and 17x9JJ forged aluminum road wheels have the ability to fully convert the high performance of the GTR V-Spec into traction and controllability. It is one of the keys to achieving a -21 second time at the Nürburgring. Suspension tuning. With the new active LSD, the Atessa ETS Pro has its own characteristics, and with the specially developed high-rigidity tires, the suspension naturally needs to be hard-tuned. The basics are of course the four-wheel multi-link suspension. As shown in the separate table, the V-Spec has improved the spring constant of the coil spring and the damping force characteristics of the shock absorber, further improving roll rigidity. This suppresses pitch and roll behavior in all driving situations, including circuit driving, and improves ground contact. It achieves a stable and faster driving experience that allows you to enjoy a close sense of unity with the car. In addition, it aims to best match the characteristics of the yaw rate feedback electric superhikas. Front brake air guide plate. The brake system is the same as the original GTR, with Brembo aluminum caliper opposed piston brakes. In order to further improve the outstanding fade resistance of the V-Spec, with an eye on racing, an air guide plate for the front brakes that is 40% larger in area than the previous model has been adopted. This is an item that guides the running wind that comes in through the ducts from the large brake cooling air intakes on the left and right sides of the front spoiler to the brake rotor section. It is attached to the tension rod of the front suspension. This significantly improves the cooling effect compared to when it is not attached. It provides further margin for braking performance when driving at the limit on the circuit. GTR V-Spec suspension data. From this data, you can see that the suspension has been significantly harder tuned compared to the original GTR. The use of a TCTS Pro and Expedia S07 tires, and the best matching of the yaw rate feedback electric superhikas. This is the result of setting the suspension characteristics in a simultaneous and complex manner with all of these elements. The journey to the Nürburgring. The total length is about 20 kilometers. There are more than 180 corners. The elevation difference is more than 300 m. The Nürburgring circuit in Germany is, so to speak, the toughest public road circuit in the world. The length of the lap, the intense ups and downs, and the continuous blind corners give the cars running there at high speed strong vertical and lateral g-forces without interruption, and continue to put psychological pressure on the driver who is steering. The reason why car manufacturers and tire manufacturers from Germany and around the world visit this place for development testing is to acquire, verify, and demonstrate the performance that can withstand such harsh conditions. That is the kind of place the Nürburgring is, where the R33 GTR V-Spec aimed for a lap time of under 8 minutes and 0 seconds. Our expedition team stayed here for several months, refining the vehicle through repeated trials. The true value of the fun of driving a car. The danger avoidance ability worthy of a high-performance car. We kept thinking about these things and kept moving our bodies. And finally, the target of -21 seconds was achieved. However, it wasn't a happy ending that came in a single leap during those few months at the Nürburgring. Many times more time and effort was spent on countless unknown aspects. The central stage for all of this was our Hokkaido Proving Ground HPG, the Rikabetsu Proving Ground. The R33 GTR made the dream come true at the Nürburgring. It was the result of days and days of rigorous testing at HPG. The latest GTR had its latest proving ground in Hokkaido. And there were the men at the wheel, aiming for -20 seconds. 3 processes to improve the ability to drive faster and more stably. Part 1. Improving basic potential to achieve the goal of the R33 GTR. Expanding the range of controllability, that is, the ability to drive faster and more stably. We went through a 3-step process. The first step was to improve the potential of the vehicle's performance. The maximum lateral and longitudinal G-forces that a car can generate are determined by the engine, vehicle weight, tires, and brakes, which in turn determine the car's potential. To achieve this, we increased the torque of the engine, improved the performance of the tires and brakes, and increased the potential of the traction itself. It all starts here. 3 processes. Part 2. Preparing the hardware to make the most of the potential. The second is preparing the hardware to make the most of the high potential. No matter how powerful the engine is, if the tires slip, the power output cannot be used anymore. Also, no matter how high the tires are, it is meaningless if the chassis performance does not make the most of the potential. Therefore, in addition to improving the suspension, we have reviewed and improved all parts related to the chassis, such as improving the body rigidity, improving the ATESA ETS and ABS, and adopting the yaw rate feedback electric super HiCas. In particular, for the V-spec, which aims for cutting-edge evolution in driving, we have further pursued the hardware to make the most of the traction. In addition to the front and rear drive force distribution and ABS, it is equipped with the ATESA ETS Pro, which comprehensively controls the active LSD. In this way, the R33 GTR has improved the performance of the car. Moves as the driver expects and does not move contrary to expectations, but this alone is not enough. HPG. A tough course for the GTR to fly. Nissan's Hokkaido Brewing Ground, HPG, Rikubetsu Automobile Proving Ground, was completed in August 1992. It is the place where the R33 GTR was thoroughly forged and infused with life. A 7.2 kilometers long country road with distinctive corners from around the world runs around the mountain that separates Rikubetsu town, located about 20 kilometers west of Lake Akan, from Kidami City to the north. Moreover, the course is set up to go up and down the contour lines, with a considerable difference in elevation. The experiment chief, who is the coordinator of the GTR's experimental development and is affectionately known as Captain by the staff, says, like the Nürburgring, one of the features here is the large difference in elevation. It's a forest course, and the ups and downs are the toughest. For example, the straight road after the first corner is a steep uphill climb. Near the top, a blind right corner awaits. There's also a jumping spot along the way, so the car will fly completely at high speeds. Also, on the downhill, there's a nearly right-angle corner at the end of the full-throttle descent. The course is designed to reproduce and evaluate the behavior of the car in extreme situations that you would never normally encounter, and to hone the potential of its dynamic performance. A blind corner awaits at the top, a hidden jumping spot, a right-angle corner at the end of a full-throttle descent, and an incredibly high speed. You can get a glimpse of the tough trials the GTR has undergone. The test staff says with a laugh, "The GTR looks more beautiful flying than any other car." Beautiful posture means that the car is in the best position to enter the next corner. This wouldn't happen if the car wasn't easy to control. The technology and tuning of the GTR to fully utilize the capabilities of all 4 wheels were honed through unimaginable tests here at HPG. From HPG to the Nürburgring, the test driver K took the wheel of the GTR at the Nürburgring. Among the A1 drivers, who hold the highest qualifications in the company for driving evaluation skills, he is particularly outstanding in his analytical ability to refine the characteristics of the car to be aimed for. During the development of the R33 GTR, he and the SED, Senior Excellent Driver, who evaluates from a more comprehensive perspective, were the core of the experimental driving, and several A1 drivers were assigned to coordinate each performance, creating what could be called the strongest lineup. He told us about his experience at the Nürburgring as follows. The level of input to the car is overwhelmingly different. That's my impression of the Nürburgring. The tires move up and down violently. For example, you go from a high-speed straight line to a course where a wall stands in front of you, and you have to turn the steering wheel immediately. And there's a blind corner. There's a repaved part of the road. Because it's high speed, the car bounces here. You'll notice that there is a commonality between the HPG and the Nürburgring course settings. The higher the performance of the car, the more essential the situation is for verifying and analyzing stability at the limit and the danger avoidance performance based on it. And the dynamic performance of the R33 GTR honed by the HPG was verified at the Nürburgring, which has extremely harsh conditions for both the car and the driver, and achieved -21 seconds. The GTR never disappoints the driver and never lets him get bored. More than 90% of the corners at the Nürburgring are blind. Moreover, one lap is more than 20 kilometers long and there are more than 180 corners. It's not something you can memorize all of in an instant. There are many cases where you enter a corner without being able to predict what's ahead. On regular roads, the rule is to slow down sufficiently, but in this test, we were supposed to enter at high speed, laps. Even so, the GTR never betrayed my trust. This time, the pace was so high that I could feel the speed I had when I tried it with the R32 GTR before, but I never felt unnecessarily nervous. The GTR told me, "Okay. You can go further." In other words, because the stability is so high, the driver can enjoy it in a way that suits their skill, says test driver K. It's true that there may be differences in driving skill between ordinary people and us test drivers. But the GTR brings out performance that matches each person's driving skill, allowing you to enjoy driving to the fullest. Looking at it from another perspective, the fun that only the GTR can offer can be enjoyed not only in sporty driving on the circuit, but also in normal driving on public roads, where you can drive safely. Some people may think that because it's easy to control, the GTR is a boring car, but the GTR will surely teach you a whole new level of driving fun, even when cornering at 60 kilometers per hour. Driving chef, test driver overwhelming speed on the circuit, honed with HPG and proven at the Nürburgring. The deep joy of driving can be felt even when driving safely on everyday roads. The GTR is such a car with such depth of character. What made this outstanding dynamic performance a reality was technology that has a tradition of being essential and innovative. The development environment represented by HPG. And above all, the builders who have always striven to create cars that are human-centered. The fact that many test drivers with exceptional evaluation and analysis capabilities have been cultivated has also been a major factor in accelerating the further evolution of the GTR. The test staff says, "Anyone can feel that a dish is delicious. However, not everyone can express in words why it is delicious. Moreover, no one can point out that a dish would taste better if one of the spices were changed when various ingredients and secret flavors are mixed together. However, it is the test driver who finds out and shows it. That is why we value the tradition that the driver's voice is the voice of God and reflect it most strongly in the GTR. Of course, it is not just about tuning the limit range. Even in everyday driving scenes by ordinary drivers, we need to be able to provide the thrilling fun that is characteristic of the GTR. This GTR has achieved that. After all, we have a team of driving chefs with the best skills and sensibilities. The favorable environment of HPG and the passion of the development staff, including the test drivers, have supported the birth of the R33 GTR. 3 Processes, Part 3. Pursuit of a car that fully utilizes the driver's abilities. No matter how skilled a driver is, if the car lacks a sense of security, he or she will not be able to fully utilize their abilities. What is important is that the information from the car to the driver is accurate, and the next driving operation can be performed reliably accordingly. In other words, the basis of a relationship of trust is the creation of a feedback cycle of driving operation information between the driver and the car. Only then will the driver feel at ease and feel like maximizing the car's performance. A car that can clearly communicate the driving conditions and road conditions to the driver is easy to drive, and the driver can make the most of his or her driving skills. From this perspective, the R33 GTR has improved suspension and body rigidity, adopted a high-precision steering gear, and improved the grip shape of the steering wheel. We have refined the handling characteristics that make it easier to grasp the vehicle's behavior and the steering information. In addition, to improve the ease of driving operations, we have also improved the GTR's dedicated seats and improved the visibility of the meter. The R33 GTR's goal of the ability to run faster and more steadily was only achieved by steadily implementing these 3 steps. One concrete example of this is the target lap time of under 8 minutes and seconds at the Nürburgring. A space that occupies happiness. The driving potential hidden in the GTR. If the tires are the final outlet that allows all of that potential to spill out without leaving anything behind. We believe that the cockpit is the most important entrance for the driver to breathe life into the GTR. It must have the functionality to promote accurate and smooth operation and visibility even at the limit, support safer driving, and be truly GTR-like. We have inherited the cockpit concept established in the R32 GTR in many areas. A low hip point close to the center of gravity of the vehicle. Pedals positioned with the feet stretched forward. A slightly upright steering wheel. A short stroke shift knob that stands upright at hand. A large diameter tachometer and speedometer that promote accurate and quick visibility. A small diameter triple meter for front torque/oil temperature/turbo boost placed on the center console. All of these items have been honed to promote trustworthy communication with the driver. In the R33 GTR, we also added a bit of wit. The carbon look surface on the meter panel. The small GTR emblem on the center console and tachometer panel. It's all a matter of feeling, so to speak. It's the extra space that the GTR offers, which has further evolved in terms of driving. All of this is to enhance the joy of occupying this cockpit and driving the GTR. The GTR is you, or you are the GTR. The close sense of unity is felt the moment you step into the cockpit. Monoform bucket seat. The monoform bucket seat is based on the seat of a Group A car and has been developed to meet the functions required for a road car. This seat, which has already been highly praised in the R32 GTR, has been inherited by the R33 GTR. Its greatest feature is the high level of holding power to support accurate driving operation and the appropriate shape that does not feel cramped. The key technology that made this possible is the inverse shape. This is a wraparound shape with a moderate R around the center. As a result of being calculated from both chiropractic medicine and ergonomics, this shape is adopted for the shoulders, sides, waist, and thighs. This minimizes the deviation of the driver's posture due to the strong lateral G-force during sports driving. It supports accurate driving operation. Furthermore, it reduces fatigue even during long periods of high-speed cruising. In addition, a quilted pattern is used in the center of the seat and seat back, further accentuating the sporty feel. Genuine leather-wrapped 4-spoke steering wheel, antibacterial specification. The steering wheel diameter is $370, inherited from the R32 GTR. The grip cross-section shape has been refined from the previous long oval shape, and has matured to a more natural grip feel. In addition, the unique ingenuity applied to the genuine leather stitching has been properly inherited so as not to cause unnecessary irritation to the palm of the hand. In general stitching, called baseball stitching, the threads cross on the surface just like a baseball, so they form small protrusions that touch the palm of the hand. In contrast, in the GTR, grooves are carved into the grip material so that the threads can fit into it, and the stitching does not allow the threads to cross on the surface. The red stitching creates a racy atmosphere, and the driver can enjoy the unique feel of genuine leather that fits comfortably in the palm of the hand without any discomfort. In addition, the shift knob and parking brake lever are also wrapped in genuine leather, providing a consistent feel with the steering wheel. It supports accurate operation not only in general driving but also in sports driving on the circuit. Large diameter tachometer with vertical 0-0 pointer. The meter cluster features a large diameter speedometer and tachometer, flanked on either side by a water temperature gauge, fuel gauge, and oil pressure gauge. The tachometer, in particular, has a vertical 0 pointer inherited from the R32 GTR, with the red zone located near the top and the pointer pointing straight down at 0x1000 RPM. This allows the driver to read the movement of the pointer in the high RPM range right in front of the red zone without having to move their eyes forward significantly. Meanwhile, the center console features a small diameter triple meter consisting of the front torque gauge, oil temperature gauge, and turbo boost gauge of the electronically controlled torque split 4WD Atessa ETS. Carbon look surface panel and GTR emblem. If the sole pursuit of driving operability leads to a dull cockpit, that is not the GTR we envision. The joy of driving as one with the GTR is nothing other than the joy of talking to the GTR. Excessive decoration and equipment just for relaxation are unnecessary, but consideration to excite the driver in a way that is characteristic of the GTR is essential. With this in mind, we have incorporated distinctive features that are not directly related to function. One of these is the carbon look surface treatment applied to the combination meter panel and the triple center console meter panel. We hope that it gives you a racing feeling. The other is the GTR emblem that is placed in several places in the cockpit. One is on the center console. The other is inside the tachometer panel. The emblem on the tachometer panel in particular stands out even more clearly when the instrument panel lighting is turned on. There are other places with emblems, but please take your time to look for them yourself. Ozone-safe fully automatic air conditioner with consideration for the impact on the environment. An ozone-safe fully automatic air conditioner that uses a new refrigerant is standard equipment. In addition to automatically maintaining the room temperature at the desired set temperature, the cooling capacity during long periods of idling and the cool-down performance that lowers the room temperature when parked for a long time under the hot sun have been greatly improved. The digital display on the control panel uses a large fluorescent display type, and the design makes it easier to check the air conditioner on off, air volume, air outlet, and set temperature. Cassette integrated AM/FM electronic tuner radio and AM/FM electronic tuner integrated cassette deck plus 4 speakers are standard equipment. As an option, a CD integrated AM/FM electronic tuner radio, 200W, 8 speakers, and a Kenwood sound cruising system with a CD auto changer control mechanism are also available. In addition, an audio-less specification is also available. A CD auto changer is available as a dealer option. Rear fog lamps. The GTR is now equipped with rear fog lamps, which make the car's presence more visible when driving at high speeds in foggy or rainy conditions.